Hi everyone, I am Discharge. Welcome back to my channel. Today I am going to solve a problem from hydraulics pipe flow. You can see here a single pipeline is connected between two reservoirs in the first case, and in the second case you are supposed to find out the diameter of the new pipeline which is added from point C to reservoir B to increase the discharge by 30%. Let's say this pipe is pipe 1 and this pipe is pipe 2 and the new pipeline is pipe 3. Let's write the diameter of this pipeline and length of this pipeline. Okay, D1 is how much? D1 is equal to 6 inch, that is 0.1524 meter, and D2 is also 6 inch, which is 0.1524 meter, and the pipeline D3 must be calculated in this problem. So this is D. Let's write the length of the pipeline also. Okay, let's go to the first case. First case, two reservoirs are connected by a single pipeline. D1 is equal to D2 is equal to D. Let's say this is D, that is 6 inch, and L is equal to L1 plus L2, that is L1 plus L2, that is 335.26 meter. I have calculated L1 and L2, that is 182.87 meter and 152.39 meter. Let's add this L1 and L2 to get the value of this length L. I have turned the length L of this pipeline L, which is L1 plus L2, and the diameter is equal to D, that is 0.1524 meter. 0.1524 meter. Then the elevation difference between the two reservoirs are given is 25 feet, that is 7.6196 meter. 7.6196 meter. Let's apply Bernoulli between A to B. Bernoulli equation between A to B. In A there is pressure 0, velocity 0, datum ZA is equal to pressure 0, velocity 0, and datum ZB plus head loss. How much is the head loss? Head loss is equal to ZA minus ZB, that is the elevation difference. I have already calculated the elevation difference, that is 25 feet, which is equal to 7.6196 meter. 7.6196 meter. Okay, I have got the head loss between two reservoirs A and B in the pipeline having diameter small d. Okay, from Darcy-Weisbach equation, I can write like HF is equal to 8F L Q square by pi square G d to the power 5. Here the friction factor is given. How much is the friction factor? 0.02 for all the pipeline. Okay, it is already given here. So I write here friction factor F is equal to 0.02 for all pipes. Okay, let's substitute all the values over here. 8 into 0.02 into L is how much? 335.26 into Q. I don't know Q. Okay, let's put it in terms of Q. Q is a discharge in the first case. Pi square, G is 9.81 and D is small d to power 5. Small d, let's write this small d. Small d is 0.1524 whole power 5. So if we do this, then we can easily find out the head loss, that is 6739.196 Q square. Okay, this is equation number 1. Let's say this is equation number 2. From equation 1 and 2, we can easily find out the discharge in the first case. That is, let's equate this equation 1 and 2. 7.6196 is equal to 6739.196 Q square. By solving this, Q is equal to how much? Q is equal to 0.033624 meter cube per second. I found out the discharge and head loss in the first case. That is, I am going to write the head loss also, that is 7.6196 meter. In two reservoirs connected by a single pipeline, the head loss is equal to the elevation difference. You know it. Okay. because the pressure head and velocity head is 0 in the reservoir, so that's why we can term the head loss is the elevation difference. I hope you understand. In the second case, you can see here a pipeline is added having diameter capital D. A single pipeline is added from the point C having diameter capital D, and we are supposed to find out this diameter. And let's go to find out the total head loss of the compound pipeline system, and let's apply the concept of equivalent pipe. The concept is that the head loss of compound system is equal to the head loss of the single pipeline, which we have already calculated before. Okay, that is the concept of the equivalent pipeline system. Let's go to find out the total system head loss. First, let's apply the continuity condition, continuity equation, Newton equation. That is, let's say this is Q1. In this case, let's say this is the second case, Q1, and this is Q2, and this is Q3. Okay, you have to deal it independently in this case, because a new pipeline is added and discharge must be increased, and it is already given the discharge is increased by 30%. So I have to write this Q1, Q2 and Q3. And from continuity equation, we can say that Q1 is equal to Q2 plus Q3. Q1 is equal to Q2 plus Q3. I write this equation number 3. I have already written equation 1 and 2. So let's write equation number 3. Okay, let's go to find out total system head loss, HF1 of this pipeline. Okay, HF1 head loss of this pipeline, single pipeline. And let's substitute this. 8 E of is 0.02 and EL1 is 182.87. Q1 square, we don't know Q1, divided by pi square G is equal to 9.81. And D1, how much is D1? D1 is 0.1524 whole power 5. So it is how much? HF1 is 3675.94 Q1 square. This HF1 is, finally we have calculated this HF1 in terms of Q1. I term this as equation number 4. Likewise, let's go to find out the head loss of this pipeline, this 2 pipeline. Okay, HF2. HF2 is equal to, let's substitute the value, 8 into E of 0.02 into EL2 is how much? EL2 is 152.39 into Q2 square divided by pi square G is equal to 9.81, and D2 how much? D2 is 0.1524 whole power 5. Okay, I have got head loss in 2 pipeline in terms of Q2. That is, let's apply the parallel pipeline head loss concept in this pipeline 2 and this pipeline 3. You can write like, you can equate the head loss of this pipeline HF2 is equal to HF3. Okay, let's equate this head loss to get some equations. Okay, let's equate the head loss. You know that the head loss of this pipeline HF2 is equal to HF3 in the parallel pipeline system. So HF2 is equal to HF3. You can quote these values also, quote it. And you can quote F also, because F is same. And you can write Q3 in terms of Q3 square is equal to you can quote this one also, and EL2 and EL3 is also same. You can quote it also, EL2 and EL3 is also same. You can write like D3 whole power 5 divided by D2 whole power 5 into Q2 square. If you substitute the value of D2, then you can get Q3 square is equal to, if you substitute the value of D2, you know D2, but you don't know D3. You are supposed to find out the diameter of this third pipeline D3. So if I substitute D2, I get the value 12163.97 Q2 square and D3 whole power 5. This is my new equation, that is equation number 6. D3, I term D3 as D, okay, because I term the value D3, that is D, diameter D. So let's write this as D. Q3 square is equal to 12163.97 Q2 square D whole power 5. This is equation number 5 now. It is given that to increase the discharge by 30%, that means Q1 is equal to Q plus 30% of Q. That means Q1 is equal to 1.3 times Q. That is given. This is the condition given. Item is equation number 7. Okay. Now let's go to the equivalent pipeline concept, that is the head loss. That is EHF is equal to how much? We have already calculated EHF is, that is EHF 7.6196. 7.6196. This is the head loss. I have already calculated the head loss, 7.6196. And let's equate the head loss to the system head loss. In this case, the head loss is added. In this case, EHF2 is equal to EHF3. Okay, you can write both are the same head loss. So for the system head loss, I have already calculated the system head loss, that is EHF1 and EHF2. You can see here EHF1 and EHF2 is the system head loss. You are not going to take EHF1 plus EHF3 because you don't know the value of diameter D. So I am going to take EHF1 plus EHF2, system head loss. Let's going to calculate system head loss of compound pipe. That is HF is equal to HF1 plus HF2. So if you equate this, you are going to get, that is HF1 plus HF2, that is 3675.94 Q1 square plus 3063.25 Q2 square. This is now another head loss of the compound pipeline system. So you can equate the head loss of the single pipeline system and compound pipeline system. This is the concept of equivalent pipe. So let's equate these two. Let's equating both. Okay, that is 7.6196 is equal to 3675.94 Q1 square plus 3063.25 Q2 square. Let's say this is equation number how much? 8. B triple I. Equation number 8. Here Q1 and Q2 both are unknown. Okay, from equation number 7 we have got Q1 is equal to 1.3 Q, and let's substitute Q from earlier. That is, we have found out Q in the single pipeline first case, that is 0.033624 meter cube per second. If you substitute over here, you are going to get Q1 as 0.043711 meter cube per second. Okay. So if you substitute this Q1 in this equation, you are going to get the value of Q2. Alright. So let's substitute this in this equation. That is 7.6196 is equal to 3675.94 into 0.043711 square plus 3063.25 into Q2 square. On solving you will get Q2 is equal to 0.013958 meter cube per second. Okay, this is this much. So we have calculated Q1 and we have calculated Q2. Okay, now we can substitute this in continuity equation to get the value of Q3. Let's substitute Q1 0.043711 is equal to Q2 is how much? 0.013958 plus Q3. By substituting all this, you can easily get Q3 as 0.029753 meter cube per second. I have also calculated Q3. Okay, I have calculated Q3, Q1, Q2 and the pipeline single discharge Q. Okay, I have calculated all the discharges over here. And now let's substitute the discharge Q2 and Q3 in equation number 6. That is, in this equation number 6, if I substitute the value of Q3 and Q2 in this equation number 6, I will get the value of the new pipeline diameter, that is D. Okay, let's substitute this over here. That is Q3 squared is equal to 12163.97 Q2 square into d to the power 5. Let's substitute this Q3. Q3 is how much? 0.029753 square is equal to 12163.97 into Q2 is how much? 0.013958 square into d to the power 5. If you solve this, you will get the diameter of the new pipeline, which can be added to increase the discharge by 30%. That is, D is equal to how much? D is equal to 0.2063 meter, that is 20.63 centimeter. Okay, I found out the diameter of the new pipeline, which is 20.63 centimeter, and this pipeline must be added from point C to reservoir B to increase the discharge by 30%. Okay, I hope you understand. For this type of problem, you can keep in touch with me. Okay, see you in the next video. Thank you so much.